Hey guys, it's me, Simple Programmer, and welcome to the second episode of the Java game programming series. And today we will make the game loop and we will initialize graphics. So, let's get started. As I said yesterday, the game loop just makes our game run the same speed on all computers, and that's important because we don't want two objects moving at different speeds on different computers. So, let's get started. So, in our run method here, we're going to want to say init. We're just gonna run an init method, which I'll make right here. So private void init. There we go. And in here we'll just init stand just short for initialization. So basically we'll just initialize stuff later on in the series here. And then we'll also do a request focus. We can do that because it extends canvas. And we'll also do we make a long last time is equal to system.nano time. And I'll explain everything at the end here. And also now we're gonna have to do double amount of ticks. This is how many updates there are going to be in a second. I'll just set it to 60.0. That's normal. Double NS one with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 divided by amount of ticks. And now we'll do double delta is equal to 0. Long timer is equal to system.current time in milliseconds, int updates is equal to 0, int frames is equal to 0, and there we go. So now we're going to do while running, and I'll create that boolean in a second. Let's make that. So we'll go up here, and we'll make, if we go up here, we can make a boolean. It's going to do private boolean running is equal to false. And here in our start method, we're going to do if we're already running, then we're just going to do return, because if we're running, why run again? And then here we're going to do running is equal to true outside of that if statement. In our stop method, same thing, except if we're not running, then we're going to do return. And down here we're going to set running is equal to false. There we go. So now if we do while running, if we're running, we can do we're going to make another long now is equal to system.nano time. I spelled system wrong. Oh my god, I can't spell today. I can't spell. See, ask me. Okay, there we go. System.nano time. And we're also going to do delta plus equal to now minus our last time divided by nanoseconds, NS, and last time is equal to now. And then we're just going to do while delta is more than or equal to 1. We're going to say tick, do our tick method. We're going to do updates plus. That's just for FPS and updates counter, delta minus. And now outside of this while loop, we're going to do our render method, which we'll create. That's going to be for graphics, and frames plus, just again for our FPS counter. And then here we're going to do if system.current time in milliseconds minus our timer is more than 1,000, and that just equals to up to 1 second. We're going to do timer. We're going to add to timer 1,000, so it resets again. And then we're going to do system dot out dot print line. This is just our FPS counter. We're just gonna do FPS plus frames plus updates plus updates. And now finally we're just gonna set frames back to 0 and updates back to 0. Okay, so let me explain to you. So basically we're saying, okay, there's this long last time. We're gonna set it to the nanoseconds since this program started. And then here we're just setting our amount of ticks per second to 60. And the nanoseconds equal to that much divided by our amount of ticks. And we use that later in our delta. And then delta, which is gonna determine how many amount of, which is gonna actually be inside our while loop down here, saying, okay, if it's more than 1, we're gonna do it, and then we're gonna put it down by 1, so that and then the amount of ticks determines that. And then long timer is equal to our current time in milliseconds, since yeah, and then updates and frames, that's just for our FPS counter. And then we're saying, while this program is running, we have another long, now is equal to system.nanotime. Now, you would say, why would there be two things equal to the exact same thing? Well, they don't equal to the exact same thing. They're equal to how long this program was before it started. So here and here, this is just probably a couple nanoseconds apart, but that amount of time matters. Now it's saying delta plus equal to now minus the last time divided by our nanoseconds. That's just a very small number, but it's adding delta to it. And keep in mind that this is running extremely fast. And then we're setting our last time is equal to now. And then we're saying while delta is more than or equal to 1, that means, okay, we're going to add to delta a very small amount, maybe 0.01, and then ding, 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 we'll keep adding that and then until it's more than or equal to 1. If it's, let's say, the program's like, okay, is delta more than or equal to 1? Yes, then we're going to do our tick method, and then we're going to add to update by 1, and we're going to put delta minus again, so it repeats all over again. And then here, we're just doing our render and frames as fast as we can, because we want to render graphics to the screen as fast as we can. Then here, system.currentTime milliseconds minus timer is more than 1,000. That just equals to 1 second. And then we're adding timer by 1,000 again, so it can keep up. And then system.out.println, our FPS counter, and it's just resetting our frames and updates. And also down here, if we exit out of our updates, if we exit out of our while running loop, we're just going to stop. So now we need to make our tick and render method, or else we'll get an error. So we're going to make private void tick. Tick just handles our logic, and private void render. So now if we run our program, we should get no errors, hopefully. And as you can see, we get a huge, crazy amount of FPS and updates. Updates is actually staying perfectly at 60. That's good. It may fluctuate a little bit to like 59 or 61, but that's fine. Okay, let's end our program off, and let's actually make our render method, initialize our graphics. So to do that, we're gonna have to create something called a buffer strategy. So buffer strategy BS is equal to, no, not new buffer strategy as you'd expect. It's actually equal to get buffer strategy, and that's a method inside our canvas. Now Control-Shift-O to import buffer strategy. And what buffer strategy basically is, okay, think of your computer as a screen, as your screen, okay? And then buffer strategy is just a screen within a screen. So basically it's just making an image inside your computer to get ready to put it up onto the actual screen. And how many buffers determines how many images there are. Now you really shouldn't go up after 3, because it really doesn't matter. No computer is fast enough to handle that. So we're gonna say if buffer strategy is equal to null, then we're just gonna make our buffer strategy. So we're just gonna do create buffer strategy, which is also included in our canvas, and in here we're gonna put 3. So that creates 3 buffers, 3 images behind our actual screen. Okay, so it's gonna say, alright, if our computer is fast enough to make up one screen before we actually put it on the screen, do that. But if there's still more time, do the second screen. Do the second image. If there's even still more time, make a 3rd image to put up onto our actual screen. So that's what it's basically doing when we say create buffer strategy. And now we're actually make our graphics. Graphics G is equal to BS buffer strategy dot get draw graphics, which is basically just our graphics. And then we Control-Shift-O to port that. And then down here we're gonna do G dot dispose and bs.show. It's just disposing of our graphics at the end of the method, and it's showing our buffer strategy. So there we go, and there we go. So let's test this out. So let's just draw an oval to the screen. Let's do g.set color.red. So let's just setting it red, and Control-Shift-O to import color, java.output color, and g.fill oval. Let's just make it at 50, 50, and coordinate starts at the top left of the screen. So at the top left there's 0 and 0x and 0y. So let's just make it 25 width and 25 height. Let's just draw a circle that at 50, 50 x and y, and 25 width and 25 height. So now if we run our program, we should get, nope, we don't get, we get a null pointer exception. Where the 89, and why is that? That's not good graphics. Yeah, that's it. Huh. 1 second, guys. I'll be right back. Okay, guys, I think I found my error. So inside the BS is null. If BS is equal to null, we also have to add a return statement, so it actually returns and doesn't initialize our graphics before we actually have it. So now if we run, we get a red circle right here. Perfect. That's exactly what we wanted. So I hope you guys enjoyed. Next time we will be creating our framework of the game. That's the game object and the handler, which are related to our entities. And you know what? Actually, before we go, I'm gonna create something. I'm gonna do int x is equal to 0 here, and in our tick method, I'm gonna do x plus plus. That's just gonna add to x1, and here in our fill oval, instead of 50 for x, I'm just gonna do x. So what that will do is it'll create an animation where the oval moves across the screen. And oh yeah, this reminds me of something. Up here, after we initialize our graphics, we should do g.clear rectangle 0, 0, our width, which is get width, and get height. So there we go. So now if we do it, we should actually see an animation. There we go. So, hope you guys enjoyed, and I'll see you next time. Peace out.